expressing lines as equations, and we're going to start seeing some of them, and I want us to warm up to one way by taking a look at some examples where just given a little teeny bit of information, we can actually graph a line. Let's check it out. Suppose we're told that the slope of a particular line is 2/3, and its y-intercept is at -1. I claim just using that information and nothing else, we can produce an accurate sketch of the graph of this line. Let me show you what I mean. Well, the y-intercept, that's an actual point we can put on here. It's at -1. The y-intercept is cross right there, so the line's somehow going to cross right there. Now, I know the slope is 2/3. Remember what that means. That's rise over run. So if I start at this point, I can get to another point by rising up 2 and running over 3. So if I rise up 2, 1, 2, and I run over 3, 1, 2, 3, that must be another point on the line. As you know, 2 points completely determine the line, so armed with those 2 points, I can take a straight edge, and I can actually produce a very accurate picture of this line. There's the graph of this line. And this really captures the spirit of what we're going to think about, which is a way of representing lines using what's called slope-intercept form. Slope-intercept form. Let's try another example together. Suppose we're told that the slope is -3 and the y-intercept is 1. What would you do? Well, you start with an anchor point. You've got to get an anchor point. The anchor point will be the y-intercept. So that's going to happen at 1. So y is 1. That's right here. And now the slope is -3. So that's going to be, remember, rise over run. And you're saying to me, hey, wait a minute. There's no over or under because it's just -3. But remember, I can always think about -3 as -3 divided by an invisible 1. So I can always write things as a rise over run if I want. So I've got a rise over run, which is -3 over 1. So I rise up -3. Negative, that means I'm actually really not going to really rise. I'm actually going to fall 3 units. 1, 2, 3. And then I'm going to run over 1. And that gets my second point. So now I've got my second point. 2 points determine the straight line. So I just take my straight edge, line it up, take a green marker, and there you have a beautiful visualization of the linear function that's described in this way. So you can see the power of just having the y-intercept and the slope, you can produce the exact line. That's the key to understanding slope-intercept form.